A lot of people keep on asking me this. How do I not miss? Well, the answer is quite simple. Let's approach this scientifically. What force is acting on that ball? Looks like something's pushing it up, and something's pulling it down. Gravity in this case.
Hold up, didn't Einstein say that gravity was not a force, but it's curvature in space-time?
Wait, you have a point. So what is gravity then? Have you ever been told to imagine space as a fabric, and mass as bending that fabric? Perhaps you've seen this visual. Allow me to tell you, it's well, not really, but it doesn't give the correct intuition. When I look at this demonstration, I think, what's pulling that ball down? Is there a 4D gravity? Is there a 5D gravity? When does it end? And what does that mean? To understand gravity more intuitively, we need to throw away all of our notions of it. First and foremost, we must establish that the speed of light is constant in every single reference frame. This can be derived from Maxwell's equations for electromagnetic waves. Now, Einstein ingeniously concluded that this meant that mass slowed down time. This means that a clock ticking at your feet, which is closer to the earth, is slower than one at your head. Sure, this is by roughly 9 billionths of a second over 80 years, or whatever that number on the screen is per second, but this is still significant. You may ask, well, that's cool. How does this help me? What does this have to do with gravity? Well, we'll have to imagine that gravity doesn't exist for that. And bear with me on this one. Imagine a stickman just suspended in space. We know he won't move thanks to our boy Newton. We can plot a space versus time graph to show how his location varies with time. Unsurprisingly, this just looks like a straight line. How does this help us? We're forgetting something though. Doesn't time vary? It'll be faster at its head and slower at its feet. We'll show this variation with a flow field, where time is moving faster the higher up we get. Let's bring our stickman back into this, and I'm sure many of you may imagine what's about to happen to our boy. But just for clarity, let's see yet another example. Imagine this super buff Giga Chad rowing a boat with a little baby rowing on the side. Now I'm sure you can imagine the faster movement of the fluid behind the strong guy causes the boat to rotate anti-clockwise. Similarly, since we always move forward in time, our stickman will rotate and move downwards. You may ask, what does this look like for us mortal 3D beings? Well, that's just gravity, isn't it? So does that mean that if time is constant, we'd all just fly off into space? Yes!